Alright, so if you watched our video from last one, the episode 1 for arrays, we used a general basic array, and we put 66 little items in it, and we played the Star Wars song on the not clock. But anyway, now what we're going to do is we are going to play the same song, same data, same results, but we're going to use the array value. Now it's set up a little bit different here. Let me show you really quick. It's got some different ways of hooking things up. They use clock or digital inputs, so it seems like there's a lot more work going on. I mean, look at, there is just all kinds of wires there, but it's actually not bad once you figure it out. That's the problem, is figuring it out. So yeah, let's tear it apart, and I'll show you what happens with it all and how they go together. And yeah, so you're wondering why I'm staring at that thing next to my head on the screen, huh? I'm looking at the difference in the steps. Now, the original one, the first one we did, there was 5 steps. When it started, it would reset the index, first step. Then it would recall the array or refresh it. And then it would display it, and then it would go to the stepper, and then it would go back up, and then hit the cycle delay, which would go back down to the index. Array value, there are 2 more steps you have to do, because you have to remember the array and then recall the array so that you get the numbers right. So after it refreshes the array set, I'll show it to you later how it does that on this one, and then it'll remember it, so it writes it in the memory, and then it'll recall it. And then it goes right back to print it out, step it out, cycle it out, and then index it out again, and it keeps going. First one had 5 steps, this one's got 7. Alright, so I get it. You're wondering, what do I mean by refreshing the array? The big long one on the left all the way. Just because you throw another number from the counter doesn't mean it's going to send a clock signal. You have to send a clock signal to the clock after you select the next pin out on the clock thingy. Yeah. So let's say we're at the first one. It's going to go set value 1, and it's going to send that array data to the remember analog. And this is where the remember and the recall, the additional 2, that's what that is for, in case you got to do some work with it. You change the array somehow. You want to be able to get it back, right? So after you gives you that, and then it's going to split the array into the 3 pieces. It's going to clock the display, do the stepper, hit the cycle delay, and then hit the index to the next one, and clock the demux over and over. You're going to look at the bottom of the array value list there, and there's a clock pin that I'm not using. The reason I'm not using that clock pin is if I was to send a signal to it, then it would send the default array set out, not the value set that has been selected. So remember that. Alright, so my little flashcard thing here says that that part's done. On to the next. Alright, so this part is going to be about entering the data into the array, right? So the data entry, and it says it sucks the same both ways, but one sucks less than the other one. Kinda. And it's true, no matter what you do. Data entry sucks, but one way sucks more than the other, or whichever way you want to say it. Let me show you what I mean, okay? Down here is the layout for the analog array value element. Now, each one of them, the component. There's 66 values. Now, each value corresponds to one note in the song. Da, 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 da. Get it? All right. So in this example, when I click on set value 1, you can see that I have the opportunity to enter all 3 of the values that I need in order to play that note, which is the actual frequency of the note. The 200 is the length of time that it's going to get played. And then the last and final value is how long it's going to wait until it plays the next note. Alright, so you only have to do this 66 times. This is the way we did it originally. Each single array had its own list of 66 items. So it would go to all 3 arrays and get the first item, and then it would go get the second item. So I basically had to make 66 clicks to put one number in, and then go 66 more times to put the second one in, and then click 66 more times to put the friggin' third number in. And that equals, says my flashcard, 198 clicks compared to 66. I'm gonna let you figure that one out. So in my view, 66 clicks versus 198 clicks, definitely the array value wins with the time and tediousness of putting in the data. But my flashcard is telling me now that we're going to get into the compiled memory use. How much does it use? What are the differences, for the program storage space and the global variable dynamic space? So let's check that one out. Alright, so honestly speaking, both ways that you do it should use about the same amount of memory. And they did. They both used, on this ESP32, 16% of program space and 4% of the dynamic memory. Let me show you. Alright, now my flashcard says that the 3 array system, the original way we did it, used 211,294 bytes and 13,648 bytes of the dynamic memory. Array value system, the one with all the little lines on it that uses the clock and stuff, the program space understandably used a little bit more because we've got that extra step involved with the demux, and then we've got the extra step involved with the remember the location and stuff. So that is understandable. But the array value system used about 5,000 more bytes than the 3 array. It used 216,402 for the program space, and then 13,600 for the dynamic memory. It used less memory that's dynamically available, which is actually really good. Alright, so the 3 array system took 33 seconds to compile. The array value system took 25 seconds to compile, which is not a big difference. And overall, the code lines that were created, the 3 array system only made like 905 code lines. And the array value system, the one with all the clock signals and shit, 4,581. And that's because of the different indexes and it actually creates different arrays. So instead of putting all the numbers in one list, it makes an array, then another one. You get the picture, so it makes a whole lot more code. It doesn't really necessarily mean, it compiled faster with more code than with the little amount. I don't understand that, but I don't know. So there it is. That's the array value and the regular array. For the video on YouTube, you can like, share, comment, but please subscribe. I need to get 1,000 before I get anything. And also, thank you to my current Patreons listed here. And if you want to, you can go to patreon.com/aka Pigeon Kicker and helps throw some support. Helps us keep me going. Why not? Peace.